vector OA represents the unit vector along x-axis, vector OB represents the unit vector along y-axis, and vector OP represents the unit vector along x-axis. L square plus m square plus n square is 1. So therefore the magnitude of this vector is 1. So unit vector in the direction of the vector is nothing but the component form of the direction cosines. Hello everyone, a warm welcome to one and all. This is Vidhyaashram ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to study about the components of vector. So in our previous session, we have learnt what is vector, how to find the magnitude and what are the types of vectors. Also, the addition of vector using triangular law as well as the parallelogram law of addition also. So let's see here, components of a vector. So here I have taken a three-dimensional axis and I have marked a point A 1, 0, 0 and B 0, 1, 0 and C 0, 0, 1 here clearly. So let me take a vector here and also a point here x 1, 1, 1. If I take any point P here whose value is x, y, z and this represents our position vector. Clearly see the distance OA here. Let's write the magnitude of vector OA. So since I have written the direction here, I can take it as a vector. So let me take the magnitude of the vector. We know that magnitude of the vector is square root of x square plus y square plus z square. So when I take the magnitude of this vector, it is square root of 1 square plus 0 square which becomes 1. Similarly, the magnitude of vector B is also 1 and magnitude of vector C is also 1. So these are all unit vectors along OX, that is x-axis, OY and OZ axis. So thus vector OA represents the unit vector along x-axis, vector OB represents the unit vector along y-axis and vector OP represents the unit vector along x-axis, and they are called as the unit vector along x-axis, y-axis and z-axis, and they are represented using I cap, J cap and K cap. So these are all the components of the position vector with respect to OP. So where I, J, K are the unit vectors along the x-axis, y-axis and z-axis. Now let me consider a vector OP here. So this is our vector whose magnitude is given by vector R. Then what is OP in terms of components of a vector? So clearly you see this distance I can take it as x. Since why I have multiplied I here, because I is a unit vector whose magnitude is 1. So x into I represents the vector component along x-axis. Similarly, this represents the vector component along y-axis and vector component along z-axis. So clearly observe this vector. So let me take the position vector OP here. From rectangular law of addition, OP here is nothing but OP1 plus P1P. So using triangular law of addition, vector OP is nothing but OP1 plus P1P. Clearly see here, this distance P1P is nothing but the distance along z-axis, whose distance is zk. So therefore I can write it as OP1 plus z into k. Let's see for OP1. What is OP1? So this is our OP1. Again using the triangular law of addition, I can write OP1 as OQ plus QP1. So I can write this as vector OQ plus vector QP1 plus ZK. What is OQ? OQ is nothing but XI. What is QP1? Clearly see this QP1 is parallel to the line OS, whose value is YJ. The distance, also the magnitude is one and the same. So therefore, OS is equal to QP1. That is why I can write this as YJ plus ZK. So what is this OP? This is our vector R. Thus, this is called as the component form of a vector where X, Y, Z are scalars. They are only the values. X is only distance from x-axis, Y is distance from y-axis, and Z is distance from z-axis. So they represents only the distance, that is a scalar. But when I multiply this with the unit vector xi, yj plus zk, since they are indicating the direction, they are called as vectors. So any vector in the coordinate system can be represented in the component form, that is vector R is equal to xi plus yj plus zk. So here x, y, z are scalars, xi, yz and zk are the vectors. So this is called as the component form of a vector. Component form of vectors. Again, to calculate the magnitude of the vector, this is one and the same, that is R is equal to square root of x square plus y square plus z square. So this is the length of the vector. So the length or magnitude of the vector. So this is same as usual as the position vector. So this is how we will express the component form of a system. So either the vector can be expressed in the coordinate system using P of x comma y comma z, where x, y, z represents the distance from x-axis, y-axis, z-axis to point P. And this is also one and the same, but this is the usual form where we represent the vector. All vectors are usually represented in the component form, or it may be also represented using the coordinate system form. Now, direction ratios of vector A. Suppose I take vector R as AI plus BJ plus CK. So, the scalars A, B, C are called as the direction ratios of the vector A. Now, when I say vector A as A1I plus A2J plus A3K. So here A1, A2, A3 represents the distance of the position vector from x-axis, y-axis, z-axis, which are scalars. So these are called as the direction ratios of vector A. Suppose if I take LMN, that is the direction cosines of vector A. If I write this in the vector form, so that Li plus Mj plus Nk, or what is L? L is nothing but cos alpha into I, M is cos beta into J, and N is cos gamma into K. So what are this? Cos alpha, cos beta, cos gamma. They represent the direction cosines of the given vector, where alpha, beta, gamma are the angles made by the position vector with x-axis, y-axis and z-axis. So this vector represents the unit vector. This represents the unit vector along the direction of vector A. So this is always a unit vector. That means the magnitude of this vector, if you take the magnitude R in terms of L square plus M square plus N square. So in the previous session we have proved that L square plus M square plus N square is 1. So therefore the magnitude of this vector is 1. Hence this vector with respect to the direction cosines is always a unit vector along the direction of the given vector. Next, write the direction ratios of the given vector. Vector A is equal to I plus 2k and hence calculate its direction cosines. So here we have to write the direction ratios of the given vector. Now we have here vector A is equal to I. There is no j component, hence we can write 0 into j plus 2k. So therefore, the direction ratios are 1, 0 and 2. So these are the direction ratios of the given vectors. Now coming to direction cosines, we know that cos alpha is always x by r. Cos beta is y by r and cos gamma is z by r, where r is equal to square root of x square plus y square plus z square. So here in the place of x, y, z, we have 1, 0 and 2. So to calculate this, 1 square is 1 plus y square is 0. So 2 square is 4. So therefore, the magnitude of the vector is 5. Now therefore, what is cos alpha? The x component by r. So what is x? 1. So it is 1 by root 5. What is cos beta? 0 by root 5, which is 0. Next, what is cos gamma? Z. What is z? It is 2 by root 5. So this is how we will calculate the direction ratios and direction cosines. Direction ratios can also be taken as ABC. That means here x, y, z can also be replaced with ABC. Irrespective of the variables, calculating the direction cosines is one and the same. Sometimes it is square root of x square plus y square plus z square. Sometimes we can also represent in the form of square root of a square plus b square c square, where a, b, c or x, y, z represent one and the same, which is the direction ratios, and r is always the magnitude of the given vector, which you will calculate using the square root of squares of direction ratios. Next, find the direction cosines of the vector. So we have here, let me take vector A is equal to I plus 2j plus 3k. So let me calculate r, which is the magnitude of the vector, which is square root of 1 square plus 2 square plus 3 square. So 1 square 1, 2 square 4, 3 square 9. So it is root 14. So therefore, cos alpha is x by r. So x by r, which is nothing but 1 by root 14. Cos beta is nothing but y by r, which is nothing but 2 by root 14. And cos gamma is nothing but z by r, which is nothing but 3 by root 14. So these are the direction cosines of the given vector. Next, two vectors, vector A and vector B are collinear if and only if there exists a non-zero scalar lambda such that vector A is equal to lambda B. So already we have studied, we can multiply a scalar lambda to a vector A. So if I say it is 2A, it is 2 times the length of A. If I say half into vector A, it is half of the length of vector A. So which means their magnitude may differ, but the direction is same and all of them are collinear vectors. So therefore, if two vectors are collinear is nothing but parallel. If they are parallel to each other, then this relation has to be satisfied. Suppose if I take vector A as a1i plus a2j plus a3k and vector B as b1i, b2j, b3k. Then vector A is parallel to vector B if and only if. So if vector A is equal to lambda B means what? Vector A by vector B is lambda. That is how all the components should satisfy the same thing. That is the x component A1 by B1 as well as the y component A2 by B2 as well as the z component A3 by B3 must be equal to some scalar quantity. Then only we say that they are collinear to each other. If all the components of x, y, z satisfy this relation, that is a1 by b1 is equal to a2 by b2 is equal to a3 by b3 is equal to some scalar quantity, then we can say that the two vectors are collinear, or the two vectors are parallel. So coming to the second point, so we know that two vectors are equal if they have same magnitude and direction. So here also two vectors are equal if and only if their corresponding components are equal. Suppose when I say vector A is equal to A1i, A2j, A3k, and vector B is equal to B1i, B2j, B3k. So, two vectors are equal if and only if their corresponding components are equal. So, we say vector A is equal to vector B if and only if x components are equal, that is A1 is equal to B1, y components are equal, that is A2 is equal to B2, and z components are equal, that is A3 is equal to B3. So, only when this condition satisfies, we can say vector A is equal to vector B. So, next one we have, show that the vectors 2i minus 3j plus 4k and minus 4i plus 6j minus 8k are collinear. So, let me take vector A is equal to 2i minus 3j plus 4k. Vector B is equal to minus 4i plus 6j minus 8k. Now let me take this as A1, A2, A3, B1, B2, B3. If two vectors are collinear, the ratios between their component must be equal to some scalar quantity. So let me take A1 by B1. So that is 2 divided by minus 4. So this is equal to minus half. Next let me take minus 3 divided by 6. This is also minus half. Also 4 divided by minus 8. This is also minus half. So clearly we have 2 by minus 4 is equal to minus 3 by 6 is equal to 4 by minus 8, which is equal to minus half. Since the ratios of the components is equal to minus half, we can say the given vectors are collinear. The given vectors are collinear. Next question. Find the values of x and y so that the vectors 2i minus 3j and xi plus yj are equal. So, when we say that two vectors are equal, only when the corresponding components are equal. So, they have given these two vectors are equal. So, what are the corresponding components? Clearly, I component is, that is x is equal to 2, and for the j component we have y is equal to minus 3. So, this is the value of x and y. Make sure that I component is equal to I component, j component to j component, and k component to k component. Next question. Let vector A is equal to I minus 2j and vector B is equal to 2i plus j. Is magnitude of A is equal to magnitude of B. Are the vectors A and B equal? Now first let us see what is magnitude of vector A. Magnitude of vector A is square root of its component. That is 1 square plus minus 2 whole square. There is no k component, so no need to write. So it is the square root of 5. Let me see for vector B, that is modulus of vector B is 2 square plus 1 square is equal to root 5. So is magnitude of vector A is equal to magnitude of vector B? Yes. Magnitude of vector A is equal to magnitude of vector B. Now the second question is, are vectors A and B equal? Look at the I component here. It is different. Here it is 1 and here it is 2. Look at the j component here. It is minus 2 and it is 1 here. So therefore, the corresponding components, are not equal. So therefore, we can say vector A is not equal to vector B. So remember, whenever the magnitude of the two vectors are equal, it is not that they must be one and the same vector. They might be different also. So to say two vectors are equal, their component should have the same values. So next we have unit vector in the direction of vector A. So I already said you, so when you take all the cosine angles in the component form of a vector, you will get a unit vector in the direction of vector A. So we have a simple formula to find the unit vector in the direction of vector A, that is A cap is equal to vector A divided by magnitude of the given vector, or we can also write it as A cap divided by A. A represents again the magnitude of the vector, that is the length of the vector. Suppose I take vector A is equal to I plus 2j minus k. So this is the vector. Then what is the unit vector in the direction of this vector? So using this, so A cap is equal to vector A. Write your vector A as it is, I plus 2j minus k whole divided by, write the magnitude of the vector. How to calculate the magnitude of the vector? That is using the scalars, that is 1 square plus 2 square plus minus 1 whole square. So we have I plus 2j minus k divided by 1 plus 1, 2, 4 root 6 we have. Or we can write the unit vector as 1 by root 6 I plus 2 by root 6 j minus 1 by root 6 k. So this is the unit vector along the direction of vector A. And what does this represent? These are all the direction cosines, L, M, N, the value of L, M, N, or cos alpha, cos beta, cos gamma. So unit vector in the direction of the vector is nothing but the component form of the direction cosines. Find the unit vector in the direction of the vector. Vector A is equal to I plus j plus 2k. So we will take A cap is equal to vector A by magnitude of vector A. So I plus j plus 2k. K, I cap, j cap, k cap divided by 1 square plus 1 square plus 2 square. So which is root 6 again. So I can write this as 1 by root 6i plus 1 by root 6j plus 2 by root 6k. So this is the unit vector along the direction of given vector. Next, find a vector in the direction of vector phi I minus j plus 2k which has magnitude of 8 units. So I need to find a vector in the direction of vector. So which is nothing but we are going to find out first the unit vector. So A cap is equal to vector A divided by magnitude of vector A. Let me take vector A as phi I minus j plus 2k and magnitude is square root of phi square minus 1 whole square 2 square. So here I'll get the vector as phi I minus j plus 2k whole divided by root 30. So this is the unit vector along the direction of the given vector. Now I need the vector whose magnitude is 8. So A cap means unit vector whose magnitude will be 1. If I want 8 times the given vector, then multiply 8 into A cap. So that is multiply 8 into, so the given vector 5i minus j plus 2k divided by root 30. Next question, find the value of x for which x is I plus j plus k is a unit vector. So here this is a unit vector, so which is A cap. Let me write A cap is x into I plus j plus k. So if I take this as unit vector, this magnitude is 1, whose magnitude is 1, given this is a unit vector. So now vector I plus vector j plus vector k is equal to 1 by x. Now let me take mod on both sides. So then this is square root of 1 square plus 1 square plus 1 square is equal to 1 over magnitude of x. So x can be taken as positive. So this is root 3. So therefore I can take x is equal to 1 by root 3. So this is the value of x. Next one, if a cap is equal to 1 by root 14 I plus 2j plus 3k, then write the direction cosines of a cap. A cap represents the unit vector. So therefore I can write a cap in the form of 1 by root 14i, 2 by root 14j plus 3 by root 14k. In any unit vector, these terms are nothing but the direction cosines. So therefore, unit vector is nothing but the component form of direction cosines. So what are the direction cosines we have here? Cos alpha, cos beta, cos gamma. So therefore, what is cos alpha? 1 by root 14. What is cos beta? 2 by root 14. What is cos gamma? 3 by root 14. So these are the direction cosines of the given unit vector. Next, find the unit vector in the direction of the sum of the vectors A and B. So we have here two vectors. Vector A is equal to 2i plus 2j minus 5k. And vector B is equal to 2i plus j plus 3k. So when you are adding any two vectors, always add the corresponding components with respect to the I, j, k. So we are adding 2 plus 2 into I, 2 plus 1 into j, minus 5 plus 3 into k. Always add the corresponding component so that A plus B is 4i plus 3j minus 2k. So this is vector A plus B. Now we need to find out the unit vector to the vector A plus B. So let us find out. So we can write it as like this, A plus B whole cap. So which is a unit vector. So which is nothing but vector A plus vector B divided by magnitude of vector A plus vector B. So here we have 4i plus 3j minus 2k. What is the magnitude? 4 square plus 3 square plus minus 2 whole square, another square root. So 16 plus 9, 25, 25 plus 4, root 29. So we have 4i plus 3j minus 2k divided by root 29. So this is the unit vector along the direction of the vector, vector A plus vector B. You can also separate it like 4 by root 29 plus 3 by root 29 minus 2 by root 29. Next one, find the sum of the vectors. Vector A, I minus 2j plus k. Vector B, minus 2i plus 4j plus k. And vector C, I minus cj minus 7k. So when you are adding two or more vectors, add the corresponding components only. So let me take here vector A plus vector B plus vector C. So this can be written as add I components first. 1 minus 2 and here we have 1 into I. Add j components. Next we have minus 2 plus 4 and here we have minus 6 with j. And k component we have 1 plus 5 and here we have minus 7 with respect to the k component. So next we have 1 plus 1 2, 2 minus 2 0, 0 into I is 0. So 0 into I. Next we have minus 2 plus 4 is 2, 2 minus 6 is minus 4. Minus 4j plus 1 plus 5 is 6, 6 minus 7 that is minus 1k. So therefore, the resultant vector A plus B plus C is minus 4j minus k. So this is the sum of the three vectors. So we'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.